Hello, everybody. This is Mr. Kusaj, and this is chapter 2-3. The title is The Remainder and Factor Theorem. Okay? Before we get into the algebra of it all, first let's talk about what factors are, what factor means. If you multiply two numbers, like 3 times 2 equals 6, those two numbers that you multiplied are called factors. So those are the numbers we're looking for, factors. If you take the 6, for example, and divide it by one of the factors, what do you get? The other factor. So if we give you one factor, like 3, we could ask you to find the other factor. How would you do it? You divide, and you'll get the other factor. We do the same thing with polynomials, okay? We use division to factor polynomials. So if we know one factor, then we can figure out the other factor. So what I'm saying here is x minus 3 times something else is equal to this long expression. Times what? Times the other factor. That's what we're looking for. And what we can do is divide. So if we divide this into this, just like 3 into 6, divide this into this, whatever the answer is, that other answer will be the other factor. Okay? So I got it all written here. I want to do it with you, so I'm going to get some fresh paper here. So the first thing you do is write it like a long division. So I want to know what x minus 3 is into 6x to the third minus 25x squared plus 18x plus 9. What is the answer that I'm going to put up here? Because that will be the other factor, right? Remember what we did up here? So this times this equals this. Those two things will be factors. Think about it, right? These two things are factors. I took the big number divided by one of the little numbers, and I got the other little number. Okay, same thing with algebra here. Okay, one thing you got to remember is when we divide, we really don't divide both of them into here, just the first one. First one into here, answer, multiply, first one into here, and so on. Okay, so what is x into 6x to the third, right? Well, this is a 1 here, so 1 into 6 is 6. X into x to the third is x squared. Okay? Now what? Now we want to see if I multiply these, what's left over so I can move it on. So 6x squared times x is 6x to the third. That's a 3. And then 6x squared times negative 3 is negative 18x squared. Okay? These two have to match because when we subtract, I'm subtracting now to see what's left over. That has to go away, right? Plus, minus, it goes away. So this is minus 25 plus 18, right? Negative, negative is plus. So minus 25 plus 18 is negative 7x squared. Okay? Bring down the next one, which is 18x. And do it all over again. X into negative 7x squared is negative 7x. Negative 7 times x is negative 7x squared. Negative 7x times negative 3 is positive 21, right? X, positive 21x. Subtract, right? Subtract. So what do you get? This is plus, this is minus, so of course that goes away. If that doesn't happen, you did something wrong. Be careful here. Positive 18, negative 21. Positive 18, negative 21 is negative 3x. And then bring down the 9, the last part. One more time and we'll be done. So x into negative 3x is negative 3. Multiply, negative 3 times x is negative 3x. Duh, that had to happen. Negative 3 times negative 3 is positive 9. And then we'll see if there's a remainder to worry about. Subtract right? Negative 3 plus 3, gone. Plus 9 minus 9, gone. So nothing left to bring down, no remainder. I'm done. Okay? So what that means is, that this times this equals this long thing, right? Just like 3 times 2 equals 6, this times this equals this. Right? You know what? Let's go back up here, just so it matches what we're doing here. This can also be written like this, right? 3 into 6 equals 2, right? So when there's no more to bring down, then you're done. You got the factors, okay? Now, I can write the factors like this, right? So I know this times this will give me the original polynomial, right? But if you look carefully, this can be factored too. Okay, don't write this down, but it's as if you had, say, 20 factors to 4 times 5, but 4 factors to 2 times 2. So one of the factors can be factored even more, right? So if you look, this can be factored even more, right? So trial and error, or use the x method, but whatever it takes, you should know that this trinomial can be factors. Trinomials can be factored. Not all trinomials can be factored, but you should try and factor it. Okay? Finally, we got all the factors of this polynomial. And how did it start? It started with us giving you one factor and you multiplying to get the other factor. And then we noticed the other factor can be further factored. Right? Okay. So what we want to move on to next is more long division, but this time with a remainder. So long division with remainder. Now let's go back to just simple numbers, right? What is 5 into 7? 5 into 7 is 1. We do the multiplication. 1 times 5 is 5. I subtract, and there is a remainder. Nothing to bring down, so I'm done. The remainder is 2. And how do we write it? Well, a long time ago you wrote it like this, right? And you could also write it like this. 1 and then 2 over whatever this number is. 1 2/5. Well, this is a mixed number, but what this means is 1 and 2/5. So you can write it with plus in the middle. We're going to do this, right? We're going to take our remainder, put it on top of whatever we're dividing. Right? That's what we're going to do. I'm hoping this comes back to you. Okay? So here we go. We want to divide this polynomial by this binomial. So what that means is we don't know if this is a factor. Well, it isn't because we're doing remainder. So we're going to divide this into this like we did before. But this time in the end, we're not going to get 0 remainder. We're going to get some sort of number in the end. Okay? The way that this long division works is you have to include all powers. Notice I'm missing a power here. This is power 3, power 1. I'm missing power 2. So I have to make up for it. Again, let me do it with you. So 3x plus 2 into 9x to the third. I need the x squared. So plus 0x squared, right? Minus x minus 3. So you have to include all the powers. Okay? So here we go. 3x into 9x squared is 3x squared. Yes? Multiply, and you get 9x to the third. 3x squared times 2 is 6x squared. Okay, so that's why we had to leave a place for the x squared there, because we knew we were going to get an x squared. So now what? Now we subtract. Wait, this is positive, So we subtract and it becomes negative. So this cancels. 0 minus 6 is negative 6x squared. Bring down. Okay, I know I'm going a little fast, but I'm doing exactly the same thing I did before. So now what? Now I do 3x into negative 6x squared, which is negative, positive, negative, is negative. 3 into 6 is 2. X into x squared is x. Multiply, it has to come to this, right? Multiply negative 2x times 3x is negative 6x squared. Negative 2x times 2 is negative 4x. Subtract, and you get, that cancels, you get negative 1 plus 4. Negative 1 plus 4 is 3x. Bring down, and you get negative 3 here. One more time. 3x into 3x is 1, positive. 1 times 3x is 3x, we expected that. 1 times 2 is 2, positive 2. Subtract, remember to subtract. That goes away. Negative 3, negative 2 is negative 5. Right? There's nothing else to bring down. This is not 0, so what do we do with this? This is a remainder. This is a remainder. So the factors are this and this, but there's a remainder. Okay? So how do we write that down? Okay, I wrote this before. So this is the remainder. How do we write it down? Well, let's write down the problem first. This is what we did, right? This divided by this. So I rewrote it in this form because it takes less space. Equals the answer plus negative 5. Remainder negative 5. And remember what we do? We put that over what we divided by. So that's how we write the remainder. So we do exactly what we did in the first example, except now we have a remainder. Okay? That's basically it. I have some try problems here that I want you to try. Get as far as you can with it, and we'll start the class with these problems. So factor this if you know x plus 6 is one of the factors. Okay, I'm telling you right now, I think this has no remainder of the way I'm asking it, right? The second one will have a remainder. Look at the way I wrote it. It doesn't matter, right? This into this, and you will get a remainder here. Here, you should come out with the remainder 0. Okay? All right. See you later for part 2. Bye.